Okay, so today we're going to talk about linear inequalities. And if you think about that, it's just like it sounds like. It's going to be linear. It's going to be just dealing with all the things we have beforehand, slope, intercept form, graphing, tables, all that. The only difference is that we're not going to have an equal symbol. We're going to have an inequality symbol. So we can still write something in slope-intercept form. It's just not going to be separated with an equal. It's going to be separated with a greater than, less than, or greater than and equal to, or less than and equal to. So a line, when we have a line on there, it represents all the solutions to a linear equation, which means if we pull a point off that line and substitute it into the equation, we would create a true statement. Whereas an inequality represents an area of solutions. So if we pull a coordinate point out of the solution area, it would create a true statement within the inequality. So when we look at it in a linear, we know in a linear equation, the solutions are on the line. In a linear inequality, the line represents a fence, where the solutions of the inequality are going to be on one side of the fence, and they may include the fence when the symbol equal to is part of the inequality. So the solutions are the area above or below the line. It's going to be one or the other. It can't be both. The way we represent that is we shade in those areas to tell us where the solutions are. When the fence is included, we represent that using a solid line. And when the fence is not included, we use a dotted line. Very similar to when we talked about range, domain and range. And when something was included, we used a certain type of bracket, or it was represented by a solid point. Versus when it wasn't included, we used a parenthesis or we used a open circle to represent that it was up to but not included. So the same deal here with linear inequalities. When we have a dotted line, the solutions are up to but not including that line. When we have a solid line, it includes all the shaded area and the line. We want to solve an inequality. We're going to do the graphing method, right? We can do substitution, but because we're not looking for a very small percentage of solutions, we have a whole area. We usually represent the solution by graphing, and we're going to first put that inequality into slope intercept form, right? That's the form that makes our graphing a little bit easier for us. So slope intercept form, but we have an inequality symbol. When dealing with the inequalities, if multiplying or dividing by a negative, the negative number, the inequality symbol flips, right? So if we multiply or divide both sides by a negative number, we're going to have to flip around that inequality. So down below, these are the inequality symbol. Typically, this is going to represent greater than or less than with the mouth opening to the bigger part. Decrease the size of that. And this is going to represent the difference, this line below. And sometimes you see it actually represented as an equal sign. That's when we know that represents the equal to part as well. Okay. So that's kind of like the basics. Now we're going to talk about how do we execute it. We're going to execute some example problems. So graphing linear inequalities, use slope and y-intercept. So we're going to, just like we graph a regular, we're going to begin with B and use slope to move and find additional points. a dashed line if we have greater than or less than, a solid line if it includes the equal to part. If y is greater than, you shade the above line. If y is less than, you shade the below line. So our first example, y is greater than 1/2 x minus 3. You can see that it's already in slope-intercept form for us. Hopefully we can recognize that negative 3 is our b, and that 1/2 is our slope. So if I'm looking on here, I'm going to see if I can insert some. Oh, there's dots underneath. Sweet. So I'm going to take my dot and first put it on negative 3. And then I know I'm going to go up 1 and over 2. Now, I don't have to represent every point. Remember, I can use equivalent fractions to kind of spread my points out to do the line. So if I went up by 3, I'd have to go over by 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. And you should remember that when we did the subtraction of fractions this week in the bell ringer, we had to change 1/2 to 3/6. So do the same thing. I'm going to go down 3 here, 1, 2, 3, and over 6. Okay. Then, of course, I'm going to use my line tool to help me draw the line. I'm going to make it a little bit thicker. Maybe not that thick. And of course, I love me some color, so I'm going to make it pink. And I'll just grab it and extend it out. But notice what I needed to do is that this is not an equal to, so I can't use a solid line. So I'm going to have to change that to a dotted line. You see, went right here where it has the line dash, and I changed it to a line dash. Okay? Now, if y is greater than this, these are greater than. These are less than, so I need to shade all of this area. So the way I'm going to do that is I'm going to use my line tool again, but I'm going to go down to a polyline, and it's going to allow me to draw a polygon. So I just hold my thing down and start, and when I release it, it allows me to change directions. And I like to see the edges of the graph so I know where the edges of the graph are, but it includes that space. And then, of course, I can pick cool color. I'm going to go a little bit lighter than the line. And this area represents that. Now, if I wasn't sure, I could find a point in this area, like 0, 0s in this area. And if I substitute that in, I'd have 0 is greater than, this would cancel out negative 3. And 0 is greater than negative 3. Okay, so that's how I know I shaded the correct area. Over here, I'm not in slope-intercept form, so I'm going to have to do that first. I'll change this to match the color of the line. So I have x minus 2y. I have to do an insert here. Insert special character, put less, and it'll come up with them. And I just put insert there. Wrong spot though. I'm just going to copy and paste it. So we have to go ahead and isolate that y. And just like we practiced yesterday, I'm going to first subtract x from both sides. And that's going to give me negative 2y. Put that copy and paste. That's the advantage of copy and pasting it. Negative x plus 8. Then I'm going to have to divide both sides by negative 2. And this is where we talked about that flip coming in. Remember, you have to divide every term on both sides. So this is going to wind up being y. And here, we're going to have to flip this. Right? So I'm going to have to insert the greater than symbol. All right, so at one point this was less than, now it's becoming greater than because I'm multiplying both sides by that negative. So that special rule comes into play. So I'm going to wind up with a negative times a negative is going to be 1/2 x, and 8 divided by -2 is -4. Y'all know I have a thing about the capitals. So y is greater than or equal to 1/2 x minus 4. So again, we have some points down here. I should recognize my b. It's my fixed number. It's going to be -4. So 1, 2, 3, 4. My slope is 1/2. So very similar to what we had over there on the other one. It's a different starting point. So we should know that these are going to look like very similar because they're in essence parallel lines. So if they were on the same graph, they would never cross. So 1, 2, 3, 4. I have to go over 8. This 4 over 8 is an equivalent fraction to 1/2. And let's see, 1, 2, 3, 4, and over 8. Hopefully you guys notice, but on the graph, these lines that are a little bit darker, those represent 5s or 5 notches. So you can use those to help you move around. So I'm going to go back and do a line. Of course, change my color to purple because that's how I roll. And then I'm going to extend this out just a little bit. And this does have the equal to, so it's a solid line. And y is greater than that, so it's still going to be above the line that gets colored in. So I go back and change my type of line to a polyline. Remember, hold down the thing, then you let it go, then it allows you to move direction. And I'm going to change that to a light purple. Okay, so really, the only additional skills that you're using in comparison to graphing with something that's not an inequality is deciding whether or not it's a dotted line or a solid line, and then doing your polyline area to represent the area of solution that exists with a linear inequality. And that's linear inequalities. For a little bit of practice, we have GP 38. So we have equations listed on slide 76. And then we have 3 pages worth of graphs already completed for you, because that's how nice we are. And all you're going to have to do is copy and paste. So you go here, and we've done this a million times. Click on one, copy it, Control C, go over to the line, and Control X, and you're going to put it right next to the number you think it matches up with.
Control V.
Control V.